What if you have multiple forces? To develop the rectangular component method for multiple forces, first consider that we have the two forces, P that has an angle theta 1 and the force Q with angle theta 2 with the x-axis. The x and y components of P and Q can be found by equations as follows. Px equals P times cosine of theta 1, Py equals P times sine of theta 1, Qx equals Q times cosine of theta 2, Qy equals negative Q times sine of theta 2. But how can we find the resultant of the forces P and Q? Because the components Px and Qx lie on the x-axis, they may be added algebraically to find the resultant in the x direction Rx. The summation of Fx means the algebraic sum of the x components of the forces. The Greek capital letter sigma means algebraic. Adding resultants in the x and y directions, Rx and Ry finds the resultant R of the force system. In this equation, Rx equals the summation of Fx equals Px plus Qx. Rectangular components can be used to find the resultant of any number of forces exactly and in a single step. The magnitude and direction of the resultant can be found from the Pythagorean theorem, and the definition of the tangent of the angle theta can also be found. R squared equals Rx squared plus Ry squared equals the summation of Fx squared plus the summation of Fy squared. The tangent of theta equals Ry divided by Rx equals the summation of Fy divided by the summation of Fx. In example 2.8, we are asked to find the resultant of the concurrent force system shown in figure A by the method of rectangular components. The x and y components of each force are determined by trigonometry, as shown in figure B. The use of a table helps organize the data and minimize computational errors. Values for each component are shown in Table A. Recall that x components are positive if they act to the right and negative to the left, and y components are positive if they act upward and negative if they act downward. The resultants in the x and y directions are given by the sums shown in the bottom of Table A. The magnitudes and direction of the resultant are determined from the Pythagorean theorem as we discussed in the previous slide. From the definition of the tangent of an angle, you can find the theta, or the arctan, from the equation r squared equals 2.058 squared plus 6.341 squared equals 44.44. R equals 6.67 kip. The tangent of theta equals Ry divided by Rx equals 6.341 divided by 2.058 equals 3.0811, which yields an angle of 72 degrees. From figure C, we can write that the resultant equals 6.67 kip at an angle of 72 degrees.